Hello everyone, let's talk about another medium problem on Leetcode today. Count number of teams, Leetcode 1395. In this problem, we are given n soldiers standing in a line. Each soldier is assigned a unique rating value. Then we have to form a team of 3 soldiers among them under the following rules. We have to choose 3 soldiers with index I, J and K with rating I, rating J and rating K. Then a team is valid if their ratings are in strictly increasing order or decreasing order. For example, for increasing order, rating I should be less than rating J, should be less than rating K. And similarly, for strictly descending order, it is rating I should be greater than rating J, should be greater than rating K. And the indices should be in the increasing order. That is, I is less than J is less than K, and then K is less than N, and I should be greater than equal to 0. So we have to return the number of teams we can form with these conditions. Soldiers can be part of multiple teams. Then they have given some examples. So in example 1, we can see that rating array is 25341 and output is 3, and we can form 3 teams given the conditions. One is 2, 3, 4, where the ratings are in strictly increasing order. Then another one is 5, 4, 1, where the ratings are in strictly decreasing order. And last one is 5, 3, 1, where the ratings are again in strictly increasing order. Then in second example, we can see that we cannot form any team at all, and that's why the output is 0. And now let's see how we can actually solve this problem. So one of the easiest way can be that actually we can run 3 nested loops to check all the possible triplets and see if they are in increasing or decreasing order. And that will be not very efficient because time complexity will be O of n cube. Another approach can be that we can actually use recursion, similar to say longest increasing sequence or longest decreasing sequence. And our sequence size at maximum can be 3, right? So let's first solve it for the ascending order case, and let's take array from example 1 for this. So we can take 2, 5, 3, 4, 1. Now let's start with index 0. So we pick up 2, and now we pick the elements which are greater than it. So we can pick 5, 3, 4. And then at next table, we try to pick elements greater than these numbers. So for example, we try to search element greater than 5. We couldn't find any. So we will return 0. So then we go to the next level. For 3, we found 4. Now we have reached the triplet size. So we will just return 1 as an answer because we found this triplet. And now we come to 4 where we couldn't find any element which is greater than 4. So we will again return 0. And now we repeat the same process for 5, 3, 4, 1 and accumulate all the counts. And that will be our answer in the ascending order. Similarly, we will do the same thing for the descending order and sum them up, and that will be our answer. And in terms of time complexity, it will be O of 2 to the power of n, where n is the number of elements in the array. Because at each step of recursion, we are checking whether we can actually pick up this element or not. And that requires O of 2 to the power of n. But if you observe carefully, this is actually a dynamic programming problem because recursion will have overlapping subproblems. So with memoization, we can actually reduce the time complexity to O of n square, but that will also involve using a cache, which will result in space complexity of O of n square. And this was another approach, but we can actually do better in terms of space complexity, and that too with a simpler solution, and that is counting. So what we can do is let's pick up index j in the array, and then we have to find elements at index I and k such that either they are in the increasing order or they are in the decreasing order, right? So let's take the ascending order case first. So let's say we find out all the elements which are actually less than rating j and count them. So let's call it A. And we find out all the elements on the right side of j which are actually greater than rating j. And let's call this one B. And because the elements are always unique, so they will be in the strictly increasing order. And then number of teams we can actually form will be A into B. And the reason for this is rating J will be in the center, but now we can pick one element out of A from the left side and then one element out of B on the right side to form one triplet. And then to form all the triplets will be A into B, because we will keep on picking one element on the left and one element on the right. And this is how we actually apply the multiplication rule of counting. Similarly, for the descending order, let the elements on the left side which are greater than rating J be C, and elements less than rating J be D. Then number of triplets will be C into D. And then our answer will be the sum of both of these. Note that we have to do it for each element in the array. So we here did it just for one number, but then we have to do it for all the elements in the array and sum them up, and that will be our answer. Now let's look at it with an example. And let's solve it for the ascending order first. Let's take the rating array as 1, 2, 3, 6, 4, 5. And let's solve it for the ascending order first. And let's take, for example, j equal to 2. That is for element 3. Then for 3, we can see that there are two elements, 1 and 2, on the left side which are smaller than 3. And there are 3 elements, 6, 4, 5, on the right side which are actually greater than 3. So if element 3 is in the middle of triplet, then we will get 6 such triplets. And the reason for this is once 3 is in the middle, we can actually take 1, 3, 6, 1, 3, 4, 1, 3, 5. Similarly for 2, it can be 2, 3, 6, 2, 3, 4, 2, 3, 5. This is how we can actually count in the ascending order. So for each element, we have to calculate the counts on the left and right side for ascending and descending order, and then take a sum of it, and that will be our answer. Now let's jump into the code part. So first thing we will do is we will start looping on all the numbers, trying to select each number as j, and count will be our answer that we will return in the end. So now we will loop j from 0 to n, and then we need 4 variables a, b, c, d, but let's name them a bit cleaner. So let's call left smaller. Let's define left smaller as number of elements on the left side which are actually smaller than the current element at j. Left greater is number of elements on the left which are greater than element at j. Similarly, right smaller is number of elements on the right which are actually smaller than element at j. And right greater will be number of elements on right which are actually greater than the element at j. And now we look on the left side. So we will start looping I from I equal to 0 to j. And now we will start updating left smaller and left greater. So if rating I is less than rating j, that means we found one element on the left which is actually less than the element j. So we will increment left smaller. Otherwise, we will increment left greater. Now we will do the same thing for k, that is elements on the right side of j. So then we learn the loop from j plus 1 to n for k. And similarly, we will check if rating k is less than rating j, then we increment right smaller, else we increment right greater. That's it. And once we do that, for the current element I, we will actually increment the count by left smaller into right greater. That is for the ascending order. And similarly, left greater into right smaller. That is for the triplets in the descending order. And once we do that, hopefully we will have the correct count and we will just return the count. Let's run this code. Oh, I have an extra s. Okay, I think that's good. Let's run this code. Awesome. Let's submit this code. Awesome. In terms of time complexity, it is O of n square because we are running two nested loops. In the outer loop, we are actually looping from j equal to 0 to n. And in the inner loop, we are actually counting the elements, which takes again O of n time. So that's why it is O of n square. And in terms of space complexity, we are not using any extra space. So it will be O of 1. So that's it for today. I hope this video was useful to you. If it was, please like and subscribe. The code link is in the description below. Have a nice time. Thank you.